तो वेलकम स्किल स्टडी सेंटर चैनल पे आपका स्वागत है। यहाँ पे हम बेसिकली सभी स्किल्स के बारे में यूजुअली बात करते हैं, लेकिन अभी जो प्रोजेक्ट हमने लिया है वो है साइकोलॉजी का BPCC 134 जो सब्जेक्ट है उसका जो इग्नू ने जो टेक्स्ट बुक दिया हुआ है उसका हम रीड कर रहे हैं। ठीक है, तो इसका वजह ये है कि शायद बच्चे जो काम कर रहे हैं कहीं पे, लेकिन पढ़ाई भी कर रहे हैं साथ में, दे आर वर्किंग एज वेल एज स्टडिंग, they might not get time to sit and idly read the textbook. So it becomes easier for them to listen to the textbook, and since you know that it is not available anywhere, so I thought of uploading it as as in textbook audio format, and hopefully you will like it because this will save your time. एंड बैकग्राउंड में जो भी नॉइस अभी हो रहा है, क्योंकि अभी ये तो वर्क प्लेस है, यहाँ पे नॉइस होगा। मैं मैक्सिमम ट्राई करूँगा कि आई बी ट्राइंग टू रिड्यूस द अमाउंट ऑफ नॉइस इन द बैकग्राउंड। मीनवाइल अभी कल तक तो मैंने सभी वीडियोस को ऑलमोस्ट यूनिट 6 तक मैंने अपलोड किए हैं, और अभी ब्लॉक 3 का यूनिट 7 जो है वो अभी मैं बना रहा हूँ, अपलोड भी करूँगा। जब तक कि आप ये वीडियो देख रहे होंगे तब तक ही अपलोड हुआ होगा ऑलरेडी। तो चलिए हम यूनिट 7 जो कि इंट्रोडक्शन टू स्टैटिस्टिक्स है इसको रीड करें। ठीक है, और सबसे पहले मैं बताना चाहता हूँ कि मेरे जो वीडियोस जो रहेंगे सब्जेक्ट्स वाइज रहेंगे और वो कंटिन्यूस आते रहेंगे। तो आपको करना है, अगर नोटिफिकेशन आना तो आपको सब्सक्राइब करना होगा। अगर आप सब्सक्राइब नहीं करोगे तो आपको नोटिफिकेशन नहीं आएगा। तो प्लीज़ सब्सक्राइब कर दीजिए अपने लिए, मेरे लिए नहीं, अपने लिए। और दूसरी बात यह है कि आपको करना है लाइक, ताकि हमें बढ़ावा मिल सके। I will feel good, right? I'm making some content and you're supporting me by giving a like. I'll feel little good. So चलिए शुरू करते हैं। ये जो इंट्रोडक्शन टू स्टैटिस्टिक्स जो है यूनिट 7 का, इससे हम शुरू करते हैं। बैकग्राउंड में जो नॉइस है उसको हम इग्नोर ही करेंगे शायद, और क्या कर सकते हैं।
Section 7.2 Meaning of Statistics 7.2.1 Definition and Nature of Statistics 7.2.2 1 Introduction A researcher is carrying out a research on emotional intelligence and self-esteem of adolescents in India. For this research, she will collect the data from the adolescents, both males and females, with the help of standardized tools for emotional intelligence and self-esteem. Emotional intelligence and self-esteem here are the two main variables of the study. After the data collection process is over, the researcher will have to carry out statistical analysis. Based on the objectives and hypothesis, S, of her research, the asterisk researcher will then use varied statistical techniques to analyze the data. She could use descriptive statistics, or she may also use inferential statistics. The researcher may compute mean and standard deviation and may even graphically represent the scores. She may also find out the percentage of adolescents with high, moderate and low emotional intelligence and self-esteem, or may want to compute the mean and standard deviation for males and females with regard to the two variables. The researcher may also choose to study relationship between emotional intelligence and self-esteem, or she may also try to find if there exists a significant difference in emotional intelligence and self-esteem with regard to gender. Thus, the researcher may choose to use varied statistical techniques based on the objectives and hypothesis, S, of her research. As it is clear from the above example, statistical methods are used in psychological research mainly to analyze data and draw inferences from them. However, before we go on to discussing various statistical techniques, we will first try to focus on the term statistics, its meaning and role. The present unit is thus fundamental to this course and will mainly introduce the term statistics. It will also focus on certain important concepts in statistics, namely, scales of measurement and descriptive and inferential statistics. 7.2 Meaning of statistics. Before we go on to develop better understanding of any subject area, we need to be clear about its basics. Keeping this in mind, in the present section of this unit, we will try to focus on the meaning of statistics and will start with defining and explaining the term statistics. 7.2.1 Definition and Nature of Statistics. What comes to your mind when the term statistics is mentioned? Well, with some description and introduction section, the first thing that may come to your mind is that it is related to numbers. Some of you may also feel that it has something to do with mathematics. Others who have studied statistics before may have a better idea about the term. In the very first section of this unit, we will try to understand the meaning of the term statistics. The term statistics finds its origin in an Italian term, statista, that is a person who deals with state-related affairs and activities. It was initially called state arithmetic, in which the information about the nation, for instance, tax-related information and war plans, were tabulated. Aaron and Coos, 2009. Thus, statistics was earlier known for its application to government-related activities and data, like census. However, today it is increasingly used in various fields like economics, psychology, education, management and so on. Statistics can be described as a branch or subfield of mathematics that mainly deals with the organization as well as analysis and interpretation of a group of numbers. Aaron and Coos, 2009. In simple terms, statistics can be described as the science of classifying, organizing and analyzing data. King and Minium, 2008, page 3. Statistics can also be explained as science that involves use of scientific and systematic methods in order to analyze numerical data related to a phenomenon and then draw inferences and conclusions from the same. Statistics can also be defined as a mathematical science pertaining to collection, analysis, interpretation and presentation of data. Viraragavan. Introduction to Statistics. 115. In Shakavakar, 2016, page 1. It can be explained as procedures that involve not only description of data but drawing of inferences as well. In this regard, it can be mentioned that statistics can be categorized into two main branches, descriptive statistics and inferential statistics. These will be discussed in detail in the last section of this unit. Besides, statistics can also be categorized as parametric and non-parametric statistics, that will be discussed in Statistical Methods in Psychological Research 2, that is a core course in semester IV. In order to understand the nature of statistics, Mohanty and Misra, 2016, highlight the following points. Statistics can be termed as a science in which the facts related to social events are observed, recorded and computed. Organization of data, its classification and analysis are the processes involved in statistics. Various events and phenomenon can be described, explained and compared with the help of statistics. A scientific inquiry can be systematically interpreted and predicted with the help of statistics. And in this regard, statistics can also help in decision-making. With the above explanation, the concept of statistics must be fairly clear in your mind. But in order to understand the term further, we need to be well aware about certain basic concepts in statistics. These concepts have been described in the subsection 7.2.2. 7.2.2 Basic Concepts in Statistics. Some of the relevant basic concepts in statistics are population, sample, parameter, statistic and variable, S. These are discussed in detail as follows. Population. The first concept relevant in statistics is population, that was discussed in Unit 2 of this course. Sample. Sample is yet another basic concept in statistics. This was also discussed in detail in Unit 2 of this course. Parameter. A parameter can be termed as a value that provides information about the population that is investigated in the research. It can be described as a measure of the population and refers to the indices of a central value, dispersion, correlation and so on of all the individuals of the population. Mohanty and Misra, 2016, page 3. For example, if a researcher wants to know mean weight of newly born infants in India in a given year, this can be termed as a parameter as it describes the weight of all the newly born infants in India in a given year. An exact parameter is not always easy to obtain and any parameter will have a statistic. Statistic. As aspects of a population are measured by a parameter, aspects of a sample are measured by statistic. Thus, the researcher will measure the weight of say 500 newly born infants, a sample representing all the newborn infants, in a given year and work out a mean weight. This mean weight can be termed as a statistic. Statistical Methods I. 116. The symbols of mean, standard deviation and variance vary for parameter and statistic. These are given in Table 7.1. Statistics as a subject area has vast scope and application. It finds its application in fields like policy planning, management, education, marketing. Introduction to Statistics. 117. Agriculture, medicine and so on, though, one of its major application is in research. Thus, our discussion in this regard will mainly focus on psychological research. But before we highlight the role of statistics in psychological research, we will try to understand the concept of research, especially in the context of psychology. Research in simple terms can be explained as adding to the existing fund of knowledge. The term research is derived from the French word recherche, which means to travel through or survey. Curlinger, 1995, page 10, defines scientific research as a systematic, controlled, empirical and critical investigation of natural phenomenon guided by theory and hypotheses about the presumed relations among such phenomena. Best and Kahn, 1999, defined research as an analysis and recording of observations that is carried out in systematic and objective manner. And this analysis and recording will lead not only to generalization but also to development of theories and predictions. Research is carried for various reasons like investigating relationships, measuring entities, making predictions, to test hypotheses, make comparisons and draw conclusions about the population. Some of the main components of research include the statement of problem, hypothesis, sample, research design, data collection and data analysis. These have been briefly discussed as follows. Problem. Problem can be described as a general objective of the study. Thus, if a researcher wants to study relationship between perceived parental behavior and self-concept of adolescence, then the statement of problem will be to study the relationship between perceived parental behavior and self-concept of adolescence. The statement of problem provides information about the general focus of the study. Further, there could also be specific objectives based on the statement of the problem. Hypothesis, plural. Hypotheses based on the statement of the problem, hypothesis, can be formulated. These are tentative statements that are tested with the help of scientific research. Hypothesis can be null or alternative hypothesis. These have been discussed under inferential statistics. Sample. Any study is carried out on a sample. The nature and size of the sample will depend on the nature and purpose of the study. Sample was discussed in detail under key concepts in statistics. Also, based on the requirement of the study, either probability or non-probability sampling techniques are used to derive the sample. Research design. Any research will also have a research design that provides information about the outline and structure of the research. Research design is important in order to not only seek solution to the research problem but also to control any variance. Thus, research design can be explained as means to allow a researcher to seek answers to research problems in an objective, valid and accurate manner, keeping in mind the economical aspect. Curlinger, 1995. There are various research designs like experimental designs, non-experimental designs, quasi-experimental designs, factorial designs, small n designs to name a few, that can be used by the researcher while carrying out research. Statistical Methods I. 118. Collection of data. The next component of research is collection of data. Data can be collected with the help of standardized psychological tests, interview method, observation, questionnaire and so on. Various methods can be used to collect data from the sample based on the objectives of the study. Data analysis. Once the data collection process is over, the data can then be subjected to data analysis, qualitatively or quantitatively, or both. In the present course, we will learn about some basic statistics techniques that can be used to analyze data. Conclusions and generalization. Based on the results obtained in data analysis, conclusions are drawn and then the researcher is in position to generalize the results to the population. The above discussed components are relevant to understand before we move on to understanding the role of statistics in psychological research. Statistics plays an important role during various stages of research. For instance, while drawing a sample from population for research, statistics can be adequately used. Sample size for a research can be determined with the help of statistics. Certain formula can be used to compute sample size. Further, in test development, statistics can be used in order to ascertain the reliability and validity of the test. Techniques like factor analysis can be used effectively for reduction of data, that also finds application in the development of psychological tests. Normal distribution can be used in development of norms. Thus, statistics can play an important role in the test development process. Statistics plays an extremely important role in analyzing quantitative data collected by a researcher. The data can be organized, classified and analyzed using various statistical techniques so as to draw inferences and conclusions and help in decision-making. The results thus obtained can be meaningfully summarized and conclusions can be drawn and predictions can be made from the same. Both descriptive and inferential statistics can be used to analyze the data. With the help of statistics, the probability of errors while drawing inferences can also be determined, thus enhancing the degree of precision. With regard to descriptive statistics, the raw data can be classified and tabulated and then measures of central tendency and measures of variability can be used based on the objectives of the research. The data can also be graphically represented for effective presentation and easy understanding. With regard to inferential statistics, two or more sample subgroups can be compared. Further, statistics can also play a role when a researcher wants to predict one or more variable from other variables. Statistics can also be categorized into parametric and non-parametric statistics based on whether certain assumptions are met. These techniques can be effectively used in varied conditions. For instance, parametric statistics has certain requirement like, the data should be normally distributed, sample needs to be homogeneous, the variables are to be measured with interval or ratio scale and so on. Non-parametric statistics can be effectively used when a sample is heterogeneous in nature, data is not normally distributed, has outliers and the variables are measured with nominal or ordinal scale and so on. Statistics can also be univariate, bivariate or multivariate. Univariate is where there is only one variable, bivariate denotes two variables and multivariate indicates many variables. Thus, based on the objectives and nature of the research, varied statistical techniques that could be as simple as computing mean and mode to more complex techniques like factor analysis, discriminant analysis and so on can be used. Thus, statistics has a major and significant role in research. In the succeeding units and the units included in the course on statistical methods for psychological research 2, that you will study in 4th semester, you will study varied statistical techniques. Interpretations of statistics. Some of limitations and misinterpretations of statistics are as follows. 1. Statistics cannot be used with single observation. To compute statistics, we need a group of data or observations. For just a single observation, statistics cannot be applied. 2. Events or phenomenon that are qualitative in nature cannot be subjected to statistics. Statistics is applicable to events and phenomenon that can be measured in terms of numbers. 3. Inferences based on statistics cannot be exact as the inferences that are drawn are based on mathematical laws. Statistical laws are based on majority of the observations and may not be applicable to each and every individual. 4. In order to adequately interpret the results of statistics, knowledge about statistics is required, especially with regard to when to use what technique and how to interpret the results obtained. Statistical Methods I. 120. 5. Statistics as such has no control over the data collection process. The results obtained will provide no indication of any dishonesty or bias in data collection. Thus, it is prone to misuse and much depends in this regard on the researcher rather than statistics. 6. Statistics may not provide a complete picture about a certain phenomenon or event. There are a number of factors that can have an impact on a certain phenomenon, but statistics will be able to measure only those factors that are quantitatively expressed. 7. The results obtained are also prone to be misinterpreted especially by untrained persons who lack knowledge about the statistical techniques, their computation and interpretation. 8. There is possibility of errors in statistical decisions. Of measurement is a process that involves assigning numbers to observations in a meaningful manner. Variations can exist in the properties of the quantification of the observations. For example, 1 kilogram of wheat is half of 2 kilograms of wheat. Here wheat is measured in terms of weight. Whereas, ranks can be assigned to students based on their performance in mathematics. For example, a student who has achieved first rank may have obtained 95 marks, whereas a student obtaining second rank may have 80 marks and a student obtaining third rank may have obtained 79 marks. As can be seen, the numerical properties in both the examples are different. In 1946, 4 scales of measurement were explained by S. S. Stevens that can be used to measure variables, Aaron and Coos, 2009. These 4 scales of measurement are described as follows. 1. Nominal scale. Nominal scale can be used to measure variables that are qualitative as well as exclusive in nature. For example, gender, religion and so on. The term nominal is derived from Latin term, nominalis, that relates to name. Though such variables are qualitative in nature, numbers can be assigned to these variables. For example, with regard to gender, males can be assigned the number 1 and females can be assigned the number 2 or vice versa. Similarly with regard to religion, Christians can be assigned the number 1, Hindus can be assigned the number 2, Jains can be assigned the number 3, Muslims can be assigned the number 4 and any other, belonging to any other religion besides the ones mentioned, can be assigned the number 5. These numbers in themselves have no Introduction to Statistics. 121. Meaning and are purely nominal. A higher number does not indicate a higher weightage. They are mainly for the sake of identification and do not imply that a certain category is better or worse than others. Thus, such numbers cannot be subjected to any mathematical calculation. For example, in sports, where teams are involved, like cricket or football, the team members have numbers on their jersey that is merely for the sake of identification and does not provide information whether one player is better than the others. 2. Ordinal scale. Ordinal scale involves ranks, that is, the data can be assigned ranks based on whether they are less or more, low or high, bad or good and so on. The data is thus ranked in terms of its magnitude. The term ordinal is derived from Latin term, ordinalis, which indicates order. For example, based on the performance of students in mathematics, they can be ranked. Thus, a student who secures first rank has performed better than a student who has secured second rank, and a student who has secured 10th rank has performed much lower when compared to the students with first and second ranks. As is with nominal scale, even in ordinal scale, the numbers cannot be subjected to any mathematical calculations. Further, in ordinal scale there is no idea about the degree of difference between the two ranks. For example, a student who has secured 75 marks in mathematics may secure first rank, a student who has obtained 65 may secure second rank, whereas a student who has obtained 64 marks may secure third rank. As can be seen in this example, the degree of difference between the marks obtained by the first ranker and the second ranker is more as compared to the degree of difference between second ranker and the third ranker. 3. Interval scale. Interval scale is most commonly used to measure psychological variables. These scales are similar to the ordinal scale as the categories can be ranked and are exclusive as well, but the degree of difference between two participants is same. For example, the degree of difference between individuals obtaining a score of 22 and another individual obtaining a score of 23 is same as that of an individual obtaining a score of 34 and another individual obtaining a score of 35. In interval scale there is no absolute zero. For example, there cannot be a person with zero attitude. Interval scale can be subjected to mathematical calculations. 4. Ratio scale. Ratio scale has all the properties of all the scales, nominal, ordinal and interval. Besides, it also has an absolute zero, that indicates presence or absence of certain property or characteristics. Ratio scale displays equidistance between the adjacent categories. For instance, the difference between 1 kilogram of wheat and 2 kilograms of wheat and difference between 5 kilograms of wheat and 6 kilograms of wheat is same. Further, 10 kilograms of wheat is half of 20 kilograms of wheat. Also, 0 kilogram indicates no wheat. Various mathematical calculations can be carried out with the help of ratio scale. Refer to Table 7.2 for properties and examples of the 4 scales of measurement. 6. Descriptive and Inferential Statistics. Statistics can be categorized into descriptive and inferential statistics. In the present section of this unit, we will explain these terms in detail. Introduction to Statistics. 123. 7.6.1 Descriptive Statistics. Let us try and understand descriptive statistics with the help of an example. A teacher administers a test on English writing skills of 100 marks to her students. As she receives the scores of the test, she comes to know that the average marks received by the class is 65. She also came to know that 10% of the students needed help with regard to English writing skills. One of her students, Tina, performed very well in the test and obtained score that was better than 85% of the students in her class. From this example, it can be seen that some of the statistical techniques that this teacher used were mean or average, percentage and percentile. These and many other techniques can be categorized under the term descriptive statistics. Descriptive statistics mainly comprises of description and organization of the data. It can be termed as a technique that helps in summarization of prominent characteristics of a distribution. Based on the properties of the sample, the descriptive statistics can be categorized into the following: Mohanty and Misra, 2016, page 7. Statistics of location covers techniques like measures of central tendency including mean, median and mode, frequency distribution, percentiles and so on. Statistics of dispersion covers techniques related to measures of dispersion including quartile deviation, standard deviation, range, average deviation and variance. Statistics of correlation includes coefficients of correlation like Pearson's product moment correlation, Spearman's rank order correlation and Kendall's rank correlation. Correlation mainly helps us understand the relationship between variables. In the present course, the main focus will be on descriptive statistics and the topics mentioned above will be covered in the subsequent units. 7.6.2 Inferential Statistics. Let us start our discussion with an example. A researcher was carrying out a study on emotional intelligence and self-concept of adolescents in South Delhi. She selected a representative sample, n equals 500, from various schools in South Delhi and administered standardized tools for emotional intelligence and self-concept on the adolescents. The researcher was interested in finding out if significant difference exists between the mean scores obtained by male and female adolescents with regard to both the variables. For this she used independent t-test and found that there was a significant difference with regard to emotional intelligence. The mean scores obtained by the female students on emotional intelligence was higher than the mean scores obtained by the male students, thus indicating that the females had higher emotional intelligence than males. However, no significant difference was found between male and female adolescents with regard to self-concept. The researcher also wanted to know if significant difference exists in emotional intelligence and self-concept with regard to the phases of adolescence, early, middle and late. For this, analysis of variance, ANOVA, was used and the results indicated that no significant difference exists with regard to either of the variables. The independent t-test and ANOVA are techniques that can be categories under Statistical Methods I. 124. Inferential statistics, the techniques that fall under inferential statistics, which will be covered in detail in the course on Statistical Methods for Psychological Research 2 that will be offered in the semester IV. In inferential statistics, inferences are drawn about the population based on a representative sample. As stated by Viraragavan and Shigavakar, 2016, page 5, inferential statistics refers to the mathematical methods based on probability theory and helps in reasoning and inferring the characteristic features of the sample drawn from the larger population. Inferential statistics can also be effectively used to make estimations and predictions. There are two types of procedures under inferential statistics, namely estimation and hypothesis testing. These two are discussed in details as follows. 7.6.2.1 Estimation. Estimating probability of a phenomenon is referred to as estimation, Viraragavan and Shigavakar, 2016. As we know from the explanation of inferential statistics, that inferences are drawn from sample that is representative of a population, and these inferences can then be generalized to the whole population. In these inferences, the researcher will make an estimation that needs to be close to the actual or true population value. There are two types of estimation, point estimation and interval estimation. Point estimation. This is a type of estimation in which the value is a single point. For example, the estimation for sample mean is made as 46.8 that is expected to be equal to the population mean. Point estimate comprises of sample mean and sample proportion. The population mean as micro, the sample mean will be x. In similar manner, if the population proportion is p, then sample proportion will be p. Interval estimation. An interval estimate is an interval or two numbers within which the population parameter could lie. Thus, for population mean, micro, the interval estimate will be a less than x less than b. The interval estimate is greater than a but lesser than b. For example, an interval estimate could be 45 to 47 within which it is expected that the population mean will lie. As the researcher has an interval, she is thus able to trust that the estimate is close to the population value with 95% or 99% level of confidence. Interval estimate comprises of confidence interval for mean and confidence interval for proportions. While estimations are made, there could be fluctuations, and these could be due to varied reasons including chance factors and sampling error. The inferences drawn by the researcher needs to be free of any chance factors. For example, a researcher is studying if there exists significant difference in job satisfaction of government and private bank employees. After carrying out data collection and data analysis, she obtains results that such a difference does exist, then such results should not be as a result of chance factors. If such a difference falls within the range plus or minus 1.96, then the significant difference can be said to be real and not due to chance factors. Fluctuations can also be as a result of sampling error that occur when the sample selected by the researcher is not representative of the population being studied. A sample that is not representative of the population will not possess. Introduction to Statistics. 125. The same characteristics as the population, and thus the results obtained from such a sample cannot be used to draw inferences for the population. Sampling errors can be avoided by being careful while selecting a sample and also by having a larger sample. 7.6.2.2 Hypothesis testing. Besides estimation, international statistics includes hypothesis testing. We discussed about hypothesis testing in Unit 1 of this course. To summarize, in the present unit, we mainly focused on the term statistics. Statistics can be described as a branch or subfield of mathematics that mainly deals with the organization as well as analysis and interpretation of a group of numbers. The term statistics finds its origin on an Italian term, statista, that is a person who deals with state-related affairs and activities. Further, the key concepts in statistics, namely population, sample, parameter, statistics and variables were also discussed. Further, the role of statistics in research was also discussed with its application from sample selection to data analysis. The limitations and misinterpretations of statistics were also discussed. The four scales of measurement, namely, nominal scale, ordinal scale, interval scale and ratio scale were discussed with examples. The last topic covered in this unit was descriptive and inferential statistics. Descriptive statistics mainly comprises description and organization of the data. It can be termed as a technique that helps in summarization of prominent characteristics of a distribution. In inferential statistics, inferences are drawn about the population based on a representative sample. Under inferential statistics, subtopics related to estimation and hypotheses testing were discussed.
दोस्तों इसी के साथ हमारा यूनिट 7 जो है वो ख़त्म हो जाता है। अभी हम आगे बढ़ेंगे, वीडियो को लेंथी नहीं करेंगे, शायद यहीं पे पॉज करके यूनिट 8 जो है वो अगली वीडियो में बनाएंगे। ठीक है, थैंक यू फॉर लिसनिंग, गिव अ लाइक।